Hello everyone, this is Wasim from Edureka, and I welcome you all to this session in which I am going to talk about exploratory data analysis in Python. So let's take a look at the agenda for this session. First of all, I am going to explain what exactly exploratory data analysis is, and then we will move on to the whole objective of doing EDA on any dataset. Moving further, I will discuss all the steps that are involved in the whole process of exploratory data analysis. And finally, we will perform EDA on a dataset from scratch. I hope you guys are clear with the agenda. Now, without any further ado, let us begin our session. So, what exactly is exploratory data analysis? Exploratory data analysis, or simply put, we can call it as EDA as well, is nothing but a data exploration technique to understand the various aspects of data. It includes several techniques in a sequence that we have to follow. And okay, we will learn about those techniques later on in the session. But the whole aim or the whole objective is to understand the data. And understanding the data can be a lot of things when we are exploring the data. So few things we have to keep in mind while exploring the data. Like we have to make sure that the data is clean and does not have any redundancies or missing values or even null values in the data set. And we have to make sure that we identify the important variables in the dataset and remove all the unnecessary noise in the data that may actually hinder the accuracy of our conclusions when we work on model building. And we must understand the relationship between the variables through EDA. And last but not the least, we must be able to derive conclusions or gather insights about the data for conclusive interpretation in order to move on to more complex processes in the data processing lifecycle. Now, let us try to understand the objective of EDA in data exploration. The very basic idea is to make sure that the data after the EDA is clean. And by clean, I mean the data has to be free of all the redundancies, including null values and all those things. So we can narrow it down to two main and basic objectives to perform EDA. So first objective is EDA helps us in identifying the faulty points in data. And if you have identified the faulty points, then you can easily remove them and clean your data. And the next objective is that EDA helps us to understand the relationship between the variables, which gives us a wider perspective on the data, and it actually helps us build on it by utilizing the relationship between the variables. So these are the main objectives of performing EDA on any data. Now let us move on and take a look at the steps involved in EDA. So these are the basic steps that are involved. So I'll just highlight the few main points, although like each step has several other features as well. So we'll take a look at those while we are working on the demo, guys. The very first and the basic step is to understand the variables in the dataset. So you have to be pretty sure about what kind of data you're working at, what are the variables like the number of columns and rows and how it actually looks like. So that is your first step after loading the data into your program. Then the next step is to clean the data from the redundancies. Now, redundancies can be irregularity in the data. It can be some variables or some columns that are not necessary for making our conclusions or interpretations. So we can just remove them, or there are outliers which can cause a noise in the data, or it may overfit or underfit the model when we are working on the model building as well. So this is the second step, guys. We have to clean the data in order to move forward. And last but not the least, we have to analyze the relationship between the variables. So let us move on to the fun part, guys. So what I will do now, I will jump right to Jupyter Notebook and we will work on a demo. I'm going to take a dataset from Kaggle and perform EDA on it. So let's take it up to Jupyter Notebook, guys. So I have already opened this notebook, guys. And if you don't already know how to work at Jupyter Notebook, we have a full tutorial on how to work with Jupyter Notebook. You can find it on our YouTube page, guys. And if you're still looking for shortcuts, like if you want to just understand how it really works, we have a cheat sheet as well, which you can refer for working at Jupyter Notebook. And if you're looking at installation and everything, we have an Anaconda tutorial as well. So the very first thing you have to do is import certain libraries that you're going to need. So I'm going to import pandas with an alias PD. I'm going to import a few other libraries that you may need. I'm going to import Seaborn for visual representation, guys, because we're going to be visualizing the relationship between the variables. So for that, I'm going to use Seaborn. So I'll run this program, and this cell is successfully running right now. It is going to take a while, guys. So meanwhile, I just want to tell you like how we are going to approach this. Okay, we have done that. So I'm going to take this variable data and I'm going to use pandas library. So first of all, the very first step is I have to import my data set, guys. So this is the location of my data sets, and name of the data set is students.csv. Okay, we have an error, guys, file not found. All right, so we have successfully imported our dataset into the program. So the very first step after you load the data into your program is you have to understand the data by understanding the variables inside your data. Okay, I'll just name it as first. So the very first step is understanding the data, and I'm going to check the first 5 rows of my data, guys. So this is my data, the first 5 rows. We have these columns like gender, race, parental level of education, lunch, test preparation course, math score, reading score, and last we have writing score. So these are the scores that are going to be important in our data set. By just looking at it, I can tell you like these are these values that will be very important while working on any model or making the assumptions or making any conclusions. Like gender has to be there because it's decisive. It has to be either male or female. So it is one categorical value that we are going to need in our data set. The race and ethnicity may be dropped. It's not necessarily a very important variable in our data set. And parental level of education, if we'll check for the unique values and we'll decide. So that is what we are going to do, perform EDA on it. Let's check the tail as well, like the last 5 rows as well. So we have all these values we have already taken a look at. So one thing you can make sure is it's starting from 0 and going until 999. So we can just say that we have 1,000 entries in this data set. So it's not a very big data set, but it's relatively not a very small data set either. It's perfect for us because while doing the representation, it's going to be quite easy for us. Now let's check for the shape of the data as well. So these are all the steps that you have to follow while working. All right. So we have checked the shape. So we have 1,000 rows and 8 columns, guys. Let's just take a look at few other key points. When you use the describe, it's only showing the math score, the reading score, and the writing score because all of the other variables that we have are string objects. Only the integer objects are showing over here. So we have a count here like 1,000, and we have a mean value, we have the standard deviation, the minimum value 25%, 50%, 75%, and the maximum value as well. So as you can see, for all those values, 100 marks is the maximum, and the minimum we have math score is 0, reading score is 17, and writing score is 10. So all these values you can just get by describe method. After that, you can just check for columns and rows separately as well. So for that, you just have to write like data dot columns. All right, it's not callable. So we have gender, race, ethnicity, parental level of education, lunch, test preparation course, math score, reading score, and writing score. So we have completed none. Okay, so we'll just check for the n unique values, which is nothing but a function which returns a series with a number of distinct observations over requested access. So if we set the value of access to be 0, then it finds the total number of unique observations over the index access. So let's just check for the unique values. So guys, what we'll do now, we'll check for the unique values in our data, guys. So I'll just use n unique, and I've already told you what it does. So for all these columns, it's showing us the unique values. So for gender, we have 2 unique values, which is basically male and female. For race and ethnicity, we have 5 values. Parental level of education, we have 6 values. For lunch, we have 2 values. For test preparation course, we have 2 values. For math score, reading score, and writing score, we have quite a few unique values. From out of 0 to 100, we have scores of 77 unique values for writing score. For reading score, we have all those things. And if you want to check separately for any column, you can just write, let's say, gender, and we can just write unique, and it will show us the unique values inside that column, guys, so which is male and female. Similarly, if you want to check, let's say, for race and ethnicity, we can check. So we have group B, group C, group A, group D, and group A. For parental level of education also we can check. All right, so we have bachelor's degree, some college, we have master's degree, associate's degree, high school, and some high school. So these are all the values that you can just make out looking at the data, guys. So by looking at these unique values, I can tell you we have categorical values like we have test preparation course, lunch, and agenda, which can be converted into the dummy values. Out of all these values, I'm just going to take these three, that is math score, reading score, and writing score, and lunch, test preparation, and gender. And the other ones like ethnicity and parental level of education can be dropped because that are not necessarily very important variables inside our data set. Now we'll move on to the next part of our EDA, which is basically nothing but cleaning the data, guys. So the very first thing that would come into your mind is check for the null values inside any of these. For that, we can just check for the null values and get a sum also. So inside this data set, we have 0 null values. So we don't have to worry about dropping any column just because there is no value or replacing it with some other values. But in some cases, in some data sets which are relatively very large, like if you have 7,000 or 8,000 values, and if you have even 2% null values or missing values inside those data set, you have to be pretty sure about either if you want to leave those values untouched, or if you want to just drop them or replace any values from them. So since we don't have any null values inside this, we'll move on to the next part, which is dropping the redundant data, which is not necessarily going to affect our performance of our table, guys. So now what we'll do is we'll remove a few columns that we don't actually need inside our data set. So we'll remove race and ethnicity and parental level of education. So these are two values that I don't need in my data set because I think these are not important values for any evaluation. So I'll just remove these. So I'll take one variable, let's say student is equal to data dot drop, and I'm gonna provide the race, ethnicity, the column name, right? And we don't want parental level of education, and it has to be access is equal to 1, otherwise it will throw us an error, right? So when I look at student, so we have all these values. We have gender, lunch, test preparation course, math score, reading score, and writing score. Next step would be like checking for outliers, which is not necessarily going to be a problem with us because we have a pretty clean data set. So you can go for outliers as well. If you want to know more about outliers, I will tell you what outliers actually are. So outliers are nothing but in statistics, an outlier is a data point that differs significantly from other observations. Let's say if you have a math score which is 72, 69, and suddenly somebody has a 0 and 1, so that is going to be an outlier. And an outlier may be due to the variability in the measurement, or it may indicate experimental error as well. So the latter are sometimes excluded from the dataset because an outlier can actually cause serious problems in statistical analysis. So that's why we have to look for outliers. And in this dataset, not necessarily we have any outliers, so we're going to leave that and move on to the third step that we have, which is basically nothing but the analysis of the, or we can call it as relationship analysis. So I'll just mark it as 3. Okay, I'll just write as relationship analysis. Now what we'll do is we'll take a look at a few other measures. So first of all, we have correlation matrix. And before we move on to relationship analysis, I hope everything is clear to you guys. Like we started from loading the data, and then we talked about how we can explore the data, look at different points in the values, and then we check for any missing values. While cleaning the data, you have to check for null values, you have to check for redundancies, outliers, and remove all the unnecessary redundant variables that we have. So we have done all that. Now we are moving on to the next step, which is also the final step, basically nothing but relationship analysis. All right, so first step I would like to do is correlation matrix, because it gives us a wider perspective on what exactly are we dealing with here. And a correlation matrix is a table showing correlation coefficients between variables, and each cell in the table shows the correlation between two variables. And correlation matrix is used to summarize data as an input into a more advanced analysis. and also as a diagnostic for advanced analysis. So we'll do that, guys. So we'll start with the relationship between the variables by looking at the correlation matrix. For that, I'm going to take one variable, let's say correlation, and I'm going to use my data, that is student, and I will take the coefficient, right? So we have no errors, guys. Now I'm going to put it inside a heat map, guys, using the SNS library that I have, or Seaborn library. SNS is basically the alias that I'm using for importing the library. So I'm going to use the heat map to actually show you what it looks like. And so we have xtech labels is equal to correlation columns, and then we have ytech labels is equal to columns, and then we'll have one more value, annotation is equal to set true. Right, we have an error, guys. So basically I forgot to add one comma over here. It should work fine now. And we have one more error, correlation. So this is our heat map, guys. So we have math score, reading score, and writing score. And we can take a look at this heat map, but since we do not have a lot of integer values, we have a few categorical values as well. So it is not necessarily that defining for our data set, but if we change these to dummy values, we'll be able to get a specific value for this. So for writing score and let's say for math score, there is a variability of 0.8, and then we have a correlation. Almost everything is same here, so we'll not rely on this. We'll move on to the next step for our data set, guys. So we're gonna plot a few other plots. So there is one pair plot we can actually plot, guys. So I'll just plot it and then tell you what it is. So pair plot, on the other hand, is when you only want to visualize the relationship between two variables, where the variables can be continuous, categorical, or booleans as well. And pair plot is usually a grid of plots for each variable in your data set. As you can see, we have a writing score, math score, and all these scores. So these are quite descriptive when you look at it. So all are in the increasing form, guys. This is also not quite decisive when we are taking a look at a conclusion, guys. So we'll move on to the next approach that we have, which is a scatter plot. So a scatter plot is a type of data display that shows the relationship between two numerical variables. Each member of a data set gets plotted as a point whose left parenthesis and right parenthesis coordinates relates to its values for the two variables. Okay, so I'm going to use the relation plot. All right, x has to be, let's say, math score. We'll take y as a reading score. We'll take the hue as gender. Data is equal to student. All right, so we have a scatter plot here, and we have added the hue as well. So as you can see, guys, for all these values that are in blue dots are actually the gender who are female, and the other one is the male counterparts, and we are having a relationship between their math score and reading score. So for all the relative values or the categorical values that we have inside our data set, which are basically nothing but test preparation course as well, and we have a lunch which has two values, so we can change the hue and check for the relationship otherwise. So instead of this, I can write lunch. So for people who had reduced and free lunch, the scores are not actually looking good. For the standard lunch people, the scores are pretty good, guys. Reading score is also quite high, and the math score is pretty good as well. This can be used to minimize our analysis, guys, because we are basically plotting three different values inside the same graph. So we have the score of two different values, that is a reading score and a math score. And then we have the hue as well, which is basically nothing but telling us the different values inside the lunch table, guys. And then similarly, we can have for test preparation course as well. So this is the scatter plot, guys, which we can use to analyze our data. And then we'll move on to the next plots that we have, which is basically nothing but a histogram. So a histogram is a graphical display of data using bars of different heights. And in a histogram, each bar groups numbers into ranges. So the taller bars show that more data range actually falls in that. And a histogram basically displays shape and the spread and continuous sample data. So now what we'll do is we'll take a look at a few histograms, guys. So for that, I'm going to use the sns.dist plot. It's going to give us distribution of, let's say, first of all, we check for math score. Right, so we have the distribution over here starting from 0. Most of the values are lying between 60 to 80. So we'll take a guess as the highest is basically highest number of people are getting the values around 60 to 70. So we'll check for other values as well. Let's say we'll check for reading score. So as you can see, we have that distribution again, and we'll check for writing score as well. All right, so all these values we can check with the histogram, guys, and we can add bins as well. So we'll take the bins is equal to, let's say, 20, or we'll take the bins to be 5. So now you can clearly see the distribution because we have only 5 divisions over here. The most values are between the 60 to 80 column. So that is how you can use the histogram to analyze the relationship between or the relationship in your data set. Right, so there's one more plot that I want to talk about, which is nothing but, all right, we'll just take the relation plot again, or we'll just take the categorical plot, and inside this, let's say x is equal to, let's say, gender. We want the kind to be box, and data is equal to student. Right, box is not defined. Cannot perform reduce with flexible type. All right, so we'll change the values, guys. So we'll take the math score. All right, so we have our box plot, guys. So for the math score, again, we are getting the same values around 60 to 80. So most of the values are falling around that. So that is how you can check the relationship. For reading score, again, you can check those values. Similarly for writing score as well. All right. So for this analysis, my suggestion would be the scatter plot, guys. That is quite easy to understand because all these values that are the averages, we can check with the describe method that we have done in the beginning, or we can just go for this one as well to understand the relationship between different variables over here, which is math score, writing score, and all those things. But in reality, we actually want the relationship between the gender and the math score. Let's say we want to check the lunch and the math score and the test preparation course and math score. For that, you're going to use the scatter plot that will just give you all the values that you actually need. So this is how you do EDA on any data, guys. So this is a relatively very small data which we had only 8 columns and 1000 values. We started with importing the data into our program, then we check for the first 5 rows, then we check for the last 5 rows what exactly was there, then we describe the data in which we had the count, the mean, the standard deviation, minimum values, and the maximum values as well for all the integer values. So you have to make sure that all these values inside your table either should be in integer values, only then you're going to get the describe function to its maximum capacity. Otherwise you would be missing a lot of values inside your table. And then of course we check for the shape and column names, which you can also take a look at when we are looking at the first 5 or last 5 rows. But the thing is, it has only 8 columns, and sometimes a few data sets, like if you're working on stock prediction, there are at least 18, 19, or maybe 200 columns that has entries in that data set. So that is one thing you have to make sure that you are able to check the shape so that you'll be able to get it, like how many rows and how many columns that you actually have. And then you can check for columns separately for all these values that we already have over here. And then you can check for unique values, for which we have, for gender we had 2. For all the values that had 2, it could be made into categorical values. Let's say we can say like lunch, if you had lunch or not. So that is going to be one categorical value, either 0 or 1, which can be categorized as say yes or no. So we'll be able to convert it into integer values for computations. And similarly for gender, if it's a male or a female, we can change it to 0 and 1 as well. And for race and ethnicity, we had 5 and 6 values for parental level of education. That was quite a challenge. So we had to remove these redundancies later on in the session while cleaning the data. And for all these math score, reading score, and writing score are pretty important in our data set. So we had to keep those. And then we actually checked for unique values of different tables so that we can make out what exactly is necessary for our table or not. Then came the second part in which we cleaned the data. So we checked for the null values. Since we had no null values inside this data set that we have, we had no problems into changing these values. So if you had any null values, let's say, you could have replaced them with drop NA. So that should have just dropped the whole row from that table. And after that, you could have replaced the values from some other values. So let's say let's say we had a few null values inside the math score. So what we would do is we would take the average, or the mean value, which is 66, and put this value inside all those null values. So it wouldn't make a lot of difference because the mean is already 66. So that is one thing that we can do while we encounter the null values inside our data. And then basically we dropped two columns that we thought are redundant to our data into analyzing any reference, but we could have used these for visual analysis. I mean, understanding the relationship. We can use parental level of education to determine how much marks a person is actually getting. So that is one thing we can use. So race and ethnicity does not really give any importance in our data, guys. It does not really manipulate anything in our data. It is just a column that we can actually drop. So we did that. After that, we took to relationship analysis. For that, we took a look at a correlation matrix. And for that, we had to calculate the correlation of the student data, and then we put it inside a heat map to check for the values. So we had not very conclusive analysis over here. So we moved to the next one, which is a pair plot. So pair plot also did the same thing, guys. So we had all these relationship between all these pair points that we had, which is a writing score, math score, and a reading score. And then the most efficient relationship analysis tool that we had found for our data is the scatter plot, guys. So we'll be able to make a few assumptions based on these, and this is quite important for us in this data, of course. And then we took a look at histogram to understand the distributions in our data, guys. And then we had used the box plot for doing the same. And after this, we can conclude a few things that we had looked into our data, guys. So for each step that we have performed over here, we can conclude one thing or the other. And the next step after this is model building, guys. So for that, you have to change a few things for your model as well. But that does not come under the EDA, guys. So let's say if you wanted to calculate or predict the gender of the person getting so and so marks in so and so column, then you would have to change a few values, like all these string values has to go and it should be converted into integer values or the dummy values like 0, 1 and all those things. And if you're looking for predictive analysis, we are going to make a tutorial on stock prediction program, guys. So hang in there. And now that we are done with this session, guys, I hope you're clear with what exactly is EDA, how we do it, and what is the objective of doing EDA on our data. Don't forget to subscribe to Edureka for more exciting tutorials, and press the bell icon to get the latest updates on Edureka. And also check out Edureka's data science certification with Python program. The link is given in the description box below. And also take a look at the data science with Python full course. You'll find a lot of advantages of learning Python for data science. Stay tuned for more tutorials with us. Thank you and have a nice day.